Hello everyone. For this lesson, I am going to discuss to you program evaluations and review techniques. It is one of those scheduling methods that you're going to learn. As a review, you've learned so far the Gantt chart, which is a universal type of scheduling method. It is one of those that are easy to understand, easy to prepare. However, the bar chart or the Gantt chart is only applicable for a small project, and they are very important if you're going to use that in conjunctions with other scheduling tools. The second method that you've learned is a critical path method. It is a critical path method because along the network diagram, you'll be able to identify the different critical activities that define the critical path. And of course, the third one that we're going to use is to learn is the PERT, the Program Evaluations and Review Technique. So what is PERT? Well, PERT is first introduced in the late or the mid 1950s to early 1960s. It is an event-oriented network analysis technique used to estimate project duration when individual activity duration estimates are highly uncertain. So for this particular type of scheduling method, it is based on probability. It is being used when uncertainties of activities are involved in the project. There's not much of a basis in regards to previous project. This was developed in the early 1960s during the time that they developed or created the Polaris missile by the Department of Defense. So again, for this particular scheduling method, it is based on probability, and you will see later on that we will be using a statistical table for us to be able to determine some of those unknown activities or unknown durations of activities. All right, so that's a little bit of a background of program evaluations and review techniques, and it's commonly used for industrial type of project. The critical path method is commonly used for any type of project, particularly for vertical constructions. All right, so there are several formulas that you will be using to evaluate the PERT. The program evaluations and review technique, it is also based on a critical path method network. We apply the PERT for those activities that are critical. So for you to be able to apply the PERT, you need to know first which activities that are within the critical path, because you will be using those critical activities for you to evaluate the likelihood of completing the project at every given period of time. All right, so on your lecture, you have those different types of formulas to which you will be calculating, such as the T subscript small letter e, that's correspond to estimated time for a given activity. We have the T capital E, that correspond to the estimated schedule time or durations for the entire project. And then we have the variance, that is a delta or the delta E subscript small e, corresponds to standard deviation. And we have also the it's a sigma with the subscript capital E, correspond to standard deviations for the entire project. And we have also the variance that we will be calculating. So again, you will notice a lot of those terms that correspond to statistics because PERT is based on the probabilistic approach. All right, so you will notice that in a given critical path, making use of the PERT, it provides you three different time estimate here. We have the optimistic TO, and most likely, that's a TM, and the pessimistic. For us to be able to estimate the durations of a given critical activity, what we need to do is take the average of those given estimated time. And I'm going to show you that as you move on. All right, so this must be the given. The project manager will be the one who will be providing those estimated numbers here. Those are the estimated duration in its optimistic, most likely, and pessimistic. Alright, for this particular problem, we were asked to determine the probability that the project will finish by the end of day 32, day 34, before day 30. So again, I want you to pay attention as you go over with those questions, because you will see here we have by the end, and here it says before. So that makes a big difference, okay? And you need to be very careful with your answer. Alright, so and there will be a questions wherein the probability will be given, and we will be asked to determine what is that likelihood of day that will give us day or schedule that will provide us a 90% confidence level. All right. So for the solution, we will be setting up a table. We will be adding three more columns that will correspond to the expected duration and each given activities. We have the standard deviations for each activity, and of course we have the variance. Again, on your notes, on the PowerPoint, on the supplementary documents, it listed down all the formulas that you will be using. All right, so these are three columns that we will be filling up. Okay, and to calculate that for each given activities, this is our formulas to be used. It is just the average, and you will notice that we have here divided by 6 because we have weighted 1 for your TO, 4 times of your TM, and 1 for your TP. And when you add all of those 1, we have 4 and 1, that's a total of 6. That's why we have here a denominator of 6. Alright, so for each given activities here, you just need to plug in the values of the TO, the TM, and the TP. Okay, and divide by 6, and you'll be able to get those individual expected duration in each of those activities that define the critical path. In the case of the standard deviation, what you need to do is just subtract the pessimistic minus the optimistic divided by 6. Plug in those numbers, and you'll be able to get the individual standard deviations in each of those given activities. Well, in statistics, when we say standard deviation, pretty much in a technical term, those are the tolerance. That's pretty much like a plus or minus that you can go above or below a given mean value. So that is the standard deviations. And of course, the next thing that we are going to calculate now is the variance. The variance is equal to the square of the standard deviation. So to calculate the variance of given activity, you just need to take the square whatever the standard deviations in each of those given activities. So you'll be able to get those individual variance. Variance is a disparity or a difference from its true value or from the mean value with that plus or minus standard deviations. Alright, so the expected duration, that's your fourth step, is just adding up the individual or the expected duration in each of those activities. So in this case here, we add up all the t small e, and it gives us here the expected durations of the project will be 32 days. And the variance of the path, or the variance for the entire project, it is just the sum of the individual variance, okay, of each given activities. Alright, so to complete the table, you just need to plug in now those values that we calculated, add up. For your capital T, it's just a sum of all of this one here. And of course, we have the capital V, is the sum of all of this one here. We will still be calculating the small, sigma capital E, which is the square root of this value here. Alright. So this is the formula. So we have all of these calculations that we have from the previous table, plug into our equation here, which is equal to the sigma E is equal to the square root of this. It is equal to 2.972 days. Alright, so how do we calculate the probability? As I mentioned a while ago, we are going to use a table, okay, and how to calculate it. Alright, so for this particular case here, and you should have that on your folder on your blackboard or in Canvas. All right, so the formula to calculate the z-value, okay, and what is this z-value here? That is a table that we have in statistics. We have here the z, and how are you going to read this one here? Say for example, if we have calculated value of say 0.25, the 10th value is on the first column, and the 100th value, or the second decimal places, are located in the rows. So if we have 0.25, we have here 0.2 plus the 0.05 here, that is 0.25. So what I do is just draw a horizontal line that go across, and then we have to draw a vertical line underneath your 0.05, and whatever the intersection of those two, that is the probability value of a given time. All right, so to calculate that, again, TS, that is the time in question to which you need to determine the probability. So in this case here, our TS is 32. That is a TS that we have here. Plug in here, that is your TS. Your TE, this one here that you have calculated from the table, 32 minus 32 divided by the standard deviation of the entire pad or your project, which is 2.972, which is equal to 0. So 0, go back into your table here. It is 0, 0, and what is that? That is 0.5. That is the probability. So that's why we have here 0.5, and that is corresponding to about 50%. Now let's go to the second problem. It says here the end of day 34. So our TS is 34. So we have here TS minus TE. That's constant. That is calculated based from our table. Divide by 2.972, and that gives you 0.67. So how do we locate that 0.67? We have here 0.6, and you have here your 0.07. So you just go scroll down. Okay, and that is this is your 0.06, go across, and that will give you 0.7486. So that is a value 0.7486, or that is 0.749, and that will give you about 75%. Okay, all right, so before day 30, so that means your TS is the 29 by the end of day 29, and that's the reason why you have here your 29. I want you to pay attention. It says end, and it says here before. So we have here 29, that's your TS, minus 32 divided by the standard deviation, and that gives you a negative. And look at this one here, we have a negative value. So how do we deal with this one? Well, in statistics, that negative value is to the left of the bell shape. The Z graph is actually resembling a bell shape. And under that particular curve, if you have a negative, that means that is to the left of that corresponding value of your Z. And to deal with that one, we will treat it as a positive for your Z. And whatever the Z value, we are going to subtract that from 1. Okay, so I repeat, you do that when we have here a negative. So get the value of your Z first in a positive 1.01, and then you subtract that from 1. Alright, so 1.01, where is that one? 1.0, and this is your 0.01. So that will give you 0.8438. 0.8438. So that's why we have here 0.8438. So I just rounded up to the next whole number because it's 8438, and then we subtract that from 1. Again, you do that when it is a negative value, which will give us here 0.156, or that is about 15.6%. So what are all of these percentages that you have calculated? Those are the confidence level, which means that if your boss will ask you what was the probability that we will be able to complete this project at day 34, well, based from your mathematical calculation, you could answer your boss by saying we should be able to finish this project at 34 days at 75% probability. You cannot just say any numbers or throw in any numbers. There must be a basis on how you calculate that percentage, and that's what we have for the PRT. All right, so for the fourth one, we have here again at the end of day 35. So this is your TS. Plug into this one here, 35 minus 32, and that gives you now the positive 1.01. And a positive 1.01, if you look into the table, that is equivalent to 0.8438, or I round that up to 3 decimal, so it gives me here 0.844, or that is 84.4%. Alright, so this is a different one here. What is given here is the confidence level. That's the 90%. That's the probability. So we will be working this in an opposite or reverse process, because we will be determining the Z value. We are asked to determine the TS. So for this 90% here, we need to find that probability that will give us a Z value. 90% of 0.9, you should not go above that, but should be slightly below that 90%. So you cannot pass that 90%. So when you look at on the Z table here, you need to find which of those here around this, in all of this number here, try to find that value that gives you close to 90%. So if we're going to look here, we have here 0.9032, 0.0915, that's still past your 90%, and we have here 0.8997, that is the one that is close but not above 90%. And what is this Z value that corresponds to this 0.8997? That is 1.2, and that is going up, and that is 0.08. So in that case, you have a 1.28 Z value. So 1.2 plus 0.08, that is 1.28. So go back to your calculation. That is your 1.28 Z. Using this formula here, I know your Z. TS, the one that you are asked to determine. You know your T that has been calculated at the beginning. We just need to plug in. We cross multiply your standard deviation to your Z. That's why we have here the standard deviations for the entire pad multiplied by your Z, and then plus your TE, because we are going to transfer this one to the left to make it positive. So we have here add, multiply, and then add, and that gives you approximately about 36 days. Alright, so again, one thing that I want to emphasize here is you need to calculate and fill up the table first, making use of these formulas. So we have step 1, step 2, step 3, and step 4, and then get all the variance for the entire pad, and then you'll be able to plug in all those numbers to complete the table. And once you've done that, you will be able to start answering the questions. The other thing that I want to emphasize is this negative value here. Okay, so for the negative value, if you're Z, treat it as a positive. However, once you get the value of a positive Z, make sure that you subtract that from 1. Okay, get the value first before you subtract. Don't use this one to subtract it from here. You need to get first the value of your Z from the table. The other thing that I want to emphasize, the third point, is pay attention on what is being asked. It says here and this one is before. So those two are different. Alright, so again, you have a supplementary documents that you can always look back, or you can always replay the video to guide you in doing your assignments or even for your exams. Alright, that is for now. Thank you.